Hello, everybody, and thank you for attending our talk on adopting Pivotal Cloud Foundry at an automobile manufacturer. So by now, you should know what kind of automobile manufacturer we are. We're Mercedes-Benz IO. Let me quickly introduce ourselves to you, but because we only have 30 minutes left and we have a lot of information, this should be really quick. So my name is Seibert. I'm the lead architect of Mercedes-Benz IO.
Yeah, hi everyone. My name is Gregor Zurowski. I'm an independent consultant and I work as a software architect for Mercedes-Benz IO since early 2016.
Okay. And just a couple of words about Mercedes-Benz IO. It's a very young company. We have been founded in November of this year. So probably you might ask yourself, why can we have so much experience and talk about the adoption of Pivotal Cloud Foundry if we're such a young company? Well, actually, we have been here before as Synteo. This is the former company which has been transformed to Mercedes-Benz IO. And we started out our journey in 2015. So we have a lot of experience in the meantime with adopting and working on Pivotal Cloud Foundry. So in order to get to know and to understand our journey with Pivotal Cloud Foundry, I think we have to go back to 2014 and look at the situation which was there in the Daimler digital clusters, so all the websites, all the marketing-related websites. And there you see the Mercedes Me portal, which is on the left side. It's customer-focused, gives information about customer data, customer registration, vehicle association, etc. Then we have the product-focused EMB side. EMB means electronic Mercedes-Benz, and this is product-related. So we have all the brand offerings, vehicles, we have dealer information, and we have functionalities such as a car configurator, which probably you all know of. And then the third side was the brand. It's Mercedes-Benz.com, and the brand shows lifestyle information, provides information about events like auto shows or Formula One news, etc. So these were three different sites. And if a visitor came to the Mercedes Me portal and then jumped to the EMB site, we didn't know anything what has happened before, so the behavior of our visitor was not clear to each of those sites because they were separate. So we had a clearly broken customer journey. And on top of that, we didn't know about the customer, so we didn't gain any knowledge, any coherent knowledge of the customer and the intentions and the purposes where he or she was on. And on top of this, we had different technology stacks. So the Mercedes Me portal works on a Java EE portal server. The EMB works on a content management system, and the brand works on a content management system as well, albeit a totally different one than the one used with EMB. So what we had to do in 2014 in order to get a coherent customer journey, we had first formulate a vision. What was the vision? We had one vision which said we want to create the best customer experience for all Daimler customers and prospects, but also for people just interested in the brand and the offerings. And for creating this best customer experience, there were three things which we had to put into focus. The first one was deliver the most relevant content to our visitors for their purpose, for their context. Second one was provide the most useful functionality for the intents the customers or the visitors are in. And as an insight, we had to stay constantly innovative and improve all the time. So this is where we created Mercedes-Benz OneWeb, the platform. The platform should unify all those contexts, all those areas of purpose, the customer, the product, and the brand, and should guarantee a coherent customer journey. And on top of this, we wanted to have a consolidated and unified technological stack, which was based on Pivotal Cloud Foundry, one content management system, analytics, and below that, an infrastructure as a service. So because we were a small company and we had a worldwide coverage of all the websites, we had to find a way how we would scale and how we would extend our work into the world. And this is why we thought about dimensions of the scaling, and we had 3 dimensions of scaling. Those were scale with content, scale with functions, and scale with market. So in a true MVP fashion, we started out with one model, which is the content dimension, one market, this is the UK market, and the core functionality, the core components which we deemed the most important for the customer experience. And then gradually, we try to scale out, get more content, cover more markets, and extend the functionality. So today is 2017, almost 2018. What have we achieved so far? We have a collaboration with more than 10 external partner companies. We had a Canary rollout to the UK in 2016 with the C-class only, limited content and limited functionality. We had the rollout in summer 2017 to Austria, and then up until now, we have rolled out in 20 countries in less than 5 months. So this means that on average, we have rolled out 4 countries a month. Sometimes we even managed to roll out 3 countries in 1 week. And this all has been done without any critical production incident. And we had 0 management escalations. So this is why we're quite confident that in the next year, 2018, we will be able to achieve more than 40 countries worldwide with our platform. So what were the architectural decisions for the OneWeb platform? How did we go on in order to achieve those goals? So we knew from the beginning that we had to build a lightweight and elastic application landscape. We knew also that we wanted to have an organizational blueprint, a startup setting. So feel like a startup, behave like a startup, have values like a startup, deliver small increments, small batches, constantly collect feedback from stakeholders, product owners, or customers, and incorporate this feedback into the next iteration. We also applied a hypothesis-driven development. So we started when a product or a project or a component by definition of a KPI or KPIs, and then we tried to, as quickly as possible, validate or verify and falsify our hypothesis, be it on a technical or a business or a logical side. So this is how we created an efficient, scalable, and extensible system for a global web presence. So this is go fast, stay focused, and be responsive. So those architectural decisions were that we had to go to the cloud in order to get the faster provisioning of virtualized hardware, in order to be more efficient with the computational things which we had to do. So we wanted to only pay when we had use of some computational compute power. And we wanted to have a cloud application platform, a PaaS, this is Pivotal Cloud Foundry, to let our teams focus on developing business capabilities and business capabilities alone. We wanted to have easy deployments to a modern container environment. Gregor will tell you a little bit about isolation, which was very important to us. And we wanted to have a ready-made outer architecture, so all the services which have horizontal functionality, service registry, configuration server, monitoring, logging, etc. This should not be done by the teams because they should concentrate on the business capability. And of course, automation was very important for us, so the configuration, the building of software, the deploying and operations should all be automated as much as possible. Then on top of the PaaS, we had a microservices-oriented architecture, so we knew that it was very beneficial to work with a microservices concept, but we wanted not to over-architect. So Martin Fowler put it like, you have to be this big to use microservices. We knew about the dangers, so we tried to experiment a little bit. If it worked out, we went on. If it didn't work out, we had to pivot or just to abandon our hypothesis. And then we defined common principles and guidelines for our whole landscape or for our whole ecosystem. And the last point was that we wanted to scale out. We wanted to let the teams develop different functionality in parallel. So we really needed speed. And this is what we try to do by isolating processes running in containers, by isolation in several steps, which also Gregor will detail later on. We needed to have independent releases, and deployments. And we made those components intercommunicate with each other by messaging or HTTP. And this is a bird's eye view from the OneWeb technological landscape. So on the right, you see the content management system, and on the left, the microservices architecture with the API gateway channeling every request. Then those different services, and on the base, we have Pivotal Cloud Foundry as the path. But we couldn't do a greenfield development, so we knew that there were many systems, many data lying in the data center of Daimler. So actually, we also had to take care of the communication between our cloud and the Daimler data center. Enabling of teams was also a very important thing for us. So we wanted to minimize the ramp-up time for a new team or a team on a new project or product. So what we had to do is to automate by PCF, or with PCF, the space creation, the permission handling, and also the service bindings. And we provided Maven archetypes for the teams so that they could build skeletons of apps and were productive probably in 1 day or 2 days, so very fast. And we tried to allow self-servicing of those teams as much as possible, so the service provisioning could be done by those teams. The usage of deployment templates let the teams customize their deployment pipelines, and we granted the teams access to monitoring and logging so that they could evaluate the behavior of their application by themselves. And we provided common components. Those components included error handling, actuator endpoint configuration, and other generic functionality. And then we tried to build ecosystem guidelines for everybody so that the teams had security in building applications for themselves, so they knew where the boundaries are and what kind of principles were guiding them in developing functionality. And we provided blueprints for documentation specification, as well as a precise definition of what a good citizen, what a good application is within our OneWeb ecosystem. So let me compare what was before and what we do now with the cloud. In the past, we had the software development life cycle, which probably is very known to you. We have the inception phase with ideation, scoping, budgeting, technical feasibility, etc. And then we gather requirements. We create architectural artifacts, and when we know what kind of hardware we need, we order those hardware at the data center. And sometimes, or very often, we had to wait at some point in time that all the hardware was available before we could deploy into an integration environment. And this waiting time was basically waste. So with Pivotal Cloud Foundry and in the cloud, at the present, we have the same inception phase. But then we don't even have to know what kind of hardware we need, because we just create a space. We create the service bindings, the service skeletons, the deployment pipelines, and the team permissions, and then the team can go on and is productive in a very short amount of time. So we have no waiting time at all. And if we compare those durations from inception to the first integration deployment, then we had earlier on about 30 days. Right now we can manage to have teams being productive and deploying onto an integration environment within 2 or 3 days. How did we achieve this in detail? This is something which Gregor now will tell you.
All right. So we want to talk about how we integrated PCF with our architecture. So one of the key things that we thought about in the inception of the project were the key principles of isolation and decoupling. We see these key principles as the main enablers to create efficiency in the teams and to make it possible that different teams work in parallel. So isolation also allows us to change parts of the system, and not affecting other parts of the system at the same time. So how do we achieve that? We are using 3 levels of isolation that PCF provides us. One level of isolation is the isolation that PCF provides natively with orgs and spaces that isolates different applications and different users. We also use PCF's containers that provides isolation on a process level, that isolates applications from each other. And we also came up with a custom versioning concept that allows us to deploy different versions of the same applications in parallel without affecting each other, effectively achieving parallel deployments of different releases. But having all these three levels of isolation, we also found that we are missing something on the platform level, on the PCF platform level. And that is that service tiles that we install. Service tiles are software components in Cloud Foundry that provide you with foundational services and data sources such as Spring Cloud Services, Gemfire, MySQL, etc. And we found that there is no isolation when you update these services. Meaning, if you have one Cloud Foundry foundation and you host different deployment environments on there, you don't have a chance to actually test the changes that a new service tile update would bring. So we were thinking about how we could actually address this issue. So what we came up with is our own setup of our Cloud Foundry environment, and we decided that we want to have separate foundations for different deployment environments. We chose an approach where we actually group some of the deployment environments to actually not waste resources, and we came up with the setup as we see it in the lower bottom of the diagram or of the slide. So we have one foundation for dev and test, we have one foundation for integration and pre-prod, and we have a separate foundation for our production environment. This now, as we can see it in the diagram, allows us to test product tile updates in a lower level environment, test it, do QA, and once we know that we are safe, propagate these changes into a higher level environment through int, pre-prod, and then eventually to prod. This follows pretty much a very traditional workflow of promoting changes, but it's essentially less complex than other approaches. It's simple, stable, and effective so far. The next thing I want to talk about is coming back to this first level of isolation that we mentioned, how PCF is able to isolate different apps and different teams. PCF provides natively a concept which is auction spaces. With auction spaces, you can actively achieve multi-tenancy on one Cloud Foundry foundation. So in our setup, as we see it in the right diagram, we give each team, each product team that provides business functionality its own space, so they can work with the highest level of freedom. They can create their services, they can push their services into their space, they can instantiate service instances without affecting other teams. We also obviously make use of roles and permissions to actually guarantee that every team member has the right access and see what the team member is supposed to see. So while having separate spaces for isolating applications and teams from each other, which is great, at the same time we're thinking about how can we provide a setup where we would have services that are shared across consumers. So there are some cross-cutting services like a service registry, which is used for service discovery, or a config server, for example, that must not be instantiated in each and every space, essentially also because you might have some global components that might need to discover services that are or applications that are hosted in different spaces. So we came up with a concept that we call shared services. So we have, as we see in the diagram, one space, shared services, where we deploy or instantiate those service instances which need to be shared. And with using PCF native mechanisms such as service keys, user-provided services, and a customized connector library, we are able to give access to these shared services to applications deployed into our business functionality areas. This concept works good, and we're still running into production, but it also comes with a couple of disadvantages. One main disadvantage is that it requires to grant space developer permissions for team members that want to have access to the service dashboard. This is obviously a problem because it's a high level of access and could be potentially dangerous. Next disadvantage that we identified in the process is that we are missing an overview of who is actually consuming our shared services, meaning that we could accidentally delete a shared service instance without knowing that there are still active consumers out there. And last but not least, there is one disadvantage that to implement our setup, we require a static naming scheme on the consumer end, because there is no tagging feature for user-provided services that does exist for regular services. But essentially, we're very happy with this setup. It has definitely advantages. It reduces the overall maintenance of these types of services, especially when it goes to updates, etc. It's also simple, stable, and effective, and it's pretty much aligned with what PCF is planning for the future, or what Pivotal is planning for the future, because Pivotal, we know, is already working on making shared services, which pretty much is similar to our setup, a first-class citizen in future versions. So let's talk about development topics. How do we develop with Cloud Foundry, and what were the major topics that we addressed? So first thing that we have thought about is an approach to versioning. We realized from the start that in a corporate environment, we will always have the requirement to run different major versions of the same application. So that was one of the main requirements that we set up. We obviously selected Semver as a versioning concept, which is a pretty safe choice. And then we decided, how do we achieve that in PCF? We decided to have every major version deployed as a separate application and running as a separate application. We only expose major versions through the API of each app, meaning we have a V1 app, we have a V2 app, etc. And this overall simplifies our development and testing approach, because now we can introduce a new major version, we can test it, we can QA it without actually doing any QA on the older version that has already been QA'd. It also simplifies the upgrades and transitioning to newer technologies, because after years that an old version was running in production and we want to come up with a new major version, we can actually opt for a new technology stack or a new language and don't have to worry to incorporate the functionality of the older version in the new version. This effectively decouples changes in business logic. So how does it look like? We see it here in a simplified diagram. We have those two white applications, versions V1 and V2, that are deployed in our environment. They are registering with our service registry with their major version. They pull their configuration from the config server, which is pulling the configuration from the backing Git repository. And now we have, on the very left, we have a client that wants to have access or wants to issue a request for the service version 2. So it hits the API gateway. The API gateway is able to translate that request into the corresponding version. It uses the service registry to discover the right application, and then the request is forwarded to the appropriate instance by the gateway. Let's talk about API gateway. We mentioned that several times, and we think that the API gateway is a core component in every microservices architecture. It essentially is an edge service that acts as a single entry point and is controlling external access to all of the services and APIs that we host in our foundation. It provides uniform endpoint behavior and a base URL and makes it very simple for clients to implement consumers against us. The API gateway has centralized responsibility for things like dynamic routing, service discovery, circuit breaking, client-side load balancing, dealing with timeouts, retries, etc. For our implementation of the API gateway, we choose Netflix Zool. It's a lightweight API gateway or edge service. It comes with a simple implementation. It's essentially a Spring Boot application that we deploy into Cloud Foundry, and it makes it very easy for us to analyze problems if such occur. It's also extensible, easily extensible with filters for fine-grained control for request processing. Some of the insights we want to share with you regarding API gateway. So first of all, what we already mentioned is it definitely provides a unified endpoint behavior that can be managed centrally. But on the other end, it also provides, currently, how we set it up now, it does not provide any self-servicing functionality for our development teams, which means if a development team comes up with a new service or comes up with a new version, we need to do some plumbing in the API gateway to enable that. That is essentially a governance task then. We also don't have any service catalog functionality, so we don't have a text document like overview of what is installed in our environment with the appropriate documentation. We also identified that it definitely has a limited feature set compared to more comprehensive API management solutions. Next thing that we want to talk about is blue-green deployments. So blue-green deployments, or zero downtime deployments, was one of the preconditions for us to actually start the project, to enable continuous deployments, and also a precondition for even just going into production. After we thought about that and did some experimentation, we also said that we need to have blue-green deployments also in lower level environments. So it's not only important to have that in production, it's also very helpful to have these in non-production environments because we are not causing any kind of outages when we apply changes to any environment, and therefore we don't cause any issues. So unfortunately, also in the inception of the project, we realized that zero downtime deployments are not first-class citizens in PCF. So essentially, if you use CF push or similar, you're essentially dragging down all the existing instances and you're starting new ones as containers, which is very nice, but you're still going to experience an outage in that time. So what you need to do is, or what we needed to do is to create a custom implementation that is following a simplified approach in our case, where we don't deal with canary deployments and we don't deal with traffic redirection. We are very happy just to be able to push applications out and don't have outages on the client end. At this point, we are able to do, or with our concept, we are able to do multiple deployments per day into production and don't cause any disruption. We also want to talk about development challenges that we have faced when we started to create the platform and create the first couple of applications. So our development stack is based mainly on Spring Boot and Spring Cloud services that we deploy to our environment, and we ran into several issues when we started. We had problems with garbage collection that led to out-of-memory exceptions or errors during Eureka communication. This was eventually fixed in Spring Cloud Services 1.1. We also had recently problems with the Spring Boot integration with the apps manager that does not work well with our custom context paths. We fixed that with a workaround. As far as I know, with Spring Boot 2.0, it's supposed to be fixed. We also identified that the recommended and documented blue-green deployments, as documented on the Cloud Foundry website, is not well aligned with the communication with Eureka. So you might even experience outages there. That's why we set up our own approach. And last but not least, another example is that we had issues with the Spring Cloud Services config server because it had a reduced feature set compared to the open source version, but also we addressed that with the Pivotal engineering team and eventually got a new version working that provides all the features that we need. One thing that we wanted to point out is that the use of Spring Cloud Services is very useful. It makes the self-servicing much easier, and we can really have features like security and high availability of important services of our infrastructure, but we also see it as an additional dependency in our overall architecture that also needs to be maintained. And on both ends, on both the infrastructure level, where when you provide or when you update your service tile and update to a new version, you're going to need to update all the service instances, but you also need to update all your client dependencies. So last section that we want to talk about some lessons learned throughout this process, or throughout our project. So one thing that is very obvious, that automation is good and provides all obvious benefits, but it's not always easy to achieve. So when we started out, we thought that we could automate everything, but we very early realized that we need to start from a very minimal set that provides us with functionality to do continuous delivery, and then increase the level of automation from there, and that would be a recommendation from our end as well. And also it's very important, as Thomas already described, it's also important to provide your developers a toolbox that they can use to automate project setup, build, and the deployments to the platform. We also learned that a PaaS solution can tremendously help you in increasing the efficiency of your team, because it automates specific tasks or many tasks, like the creation of PCF routes when you deploy application. You don't have to worry about this. You have service binding, which implements the concept of attached resources in, like described in 12-factor apps, where you don't have to worry about managing credentials by the development teams. And it's also extremely easy to scale in and out. But platform as a service systems are no panacea for everything. There is definitely considerable effort that we put into maintaining the platform. So it's no one-click installation and then you don't have to worry about anything. Still, you need to plan for having an ops team that manages the system. Also, we found that we are still missing some major functionality in PCF. Things like a built-in monitoring and alerting system is still not available. So if you plan to implement this platform, plan to use some other external products to do these for you. There is also, as we already described, there is no out-of-the-box blue-green deployments, but that will potentially get addressed in future PCF versions. We have no multi-versioning of tiles, which could also tremendously help to change our current foundation setup. And also, one smaller thing is that we think that the container-to-container networking that should work across orgs and spaces could be simplified for the users. On an organizational level, we think that you should treat your development team as customers to be successful with this platform, meaning that it is a complex system and there are many things to consider. So get their feedback and incorporate that in growing your platform. Only like this you will be successful. And also, because of the complexity of the platform, it's also extremely important to put some effort into onboarding new team members, because they might not know all the concepts of 12-factor apps or generally working with cloud environments. Thomas, do you want to jump in and also share some lessons learned?
This is the last slide on a higher level. I wanted to tell in this last slide what kind of lessons we have learned or what kind of experience we've made with Pivotal Cloud Foundry and PaaS, or cloud-native application implementation. The first one is provisioning of a centrally managed platform drastically improves the velocity of the teams, and it also improves the stability of the components. Then the isolation and the decoupling of components and teams is paramount for parallel development. You cannot have a multitude of teams without isolating those teams and decoupling those teams with deployments, with the container processes, etc., as Gregor put it in detail a couple of minutes ago. And the last thing is, if you turn to a microservice-oriented architecture, your organization has to change as well. So if you have an organization which was not accustomed to have multiple teams, very fast velocity, iterations, then this is one thing exactly as the agile model. Your organization has to change in order to pull the most profit from a microservice-oriented architecture. So this basically is it. Thank you very much for your attention. If you have any questions, then this is the best time to ask. So you have to, of course it's dependent on what your organization looks like when you start your journey. But if you have, for example, if you have a hierarchical organization, this is not going to work with a microservice-oriented team setup. You have team setups where the teams should be self-responsible. They should be, they should have as much freedom as possible in order to develop, and they should have the freedom of doing the iterations in a very fast manner. Yeah. So probably Daimler was not really known for agile development. I think it's safe to say that. But when we started out, it's a gradual development. So once you really see that this is happening and it really gives you some power and some velocity and some stability, I think everybody involved really can turn to that. And this is, for us, it was a very gradual development, but right now I see that we, in all our teams, have a very agile, very iterative and incremental development. So I think this is also something where Daimler has changed a lot within the last 2 or 3 years.
All right. There's another question there.
So first, you say each team has their own space?
Right.
So the question was...
the question is
has its own space.
That's correct. In our setup, each team gets their own space to actually isolate any type of applications and service instances from each other. Yeah, we have parent organizations, so for this project we have one parent organization, that is correct. We might change that setup, we started out like that, we might change that setup because with PCF, I think 1.10, you have isolation segments and things like that, so we might change things around, but for the current setup, it's a working setup for us.
Yes.
You centralize the config server, right?
Mm-hmm.
So the provisioning of the service itself, let's say for one application, how do you, say, take care of the specific configuration of each and every application that needs you, especially the configuration for you?
So the question is how we can manage a central config server and extend it to other applications. So there are several things that we did. We also went through a couple of iterations there, also because we had some features that were not there and were added with config server later. And we started out to use things like the placeholders in the beginning, where we had different config repositories, and we could address them from the config server perspective with placeholders. So if an application that was called service 1 was requesting its configuration from the service, we used that placeholder service 1 and were dragging in or pulling in the correct configuration. And later on, we changed the setup because of security concerns. And at this point, it's also a task that we want to automate. But at this point, we are adding separate configuration repositories with separate credentials just to increase the level of security. Does that answer your question? Okay, yeah, sure. Feel free to approach us.
If you have any questions which have to be discussed in detail, just approach us after the talk, and we're more than happy to discuss this with you. Good. So, thank you very much. Oh, sorry.
How do you manage naming convention cloud foundry?
Yes. So in the very beginning, so the question is how we manage application names and whether we came up with a convention. Yes, so when we started the project, we actually gave it some thought, and we came up with a concept of using only acronyms. And when a new application is created or a new team creates a new application, they will actually ask us for appropriate acronym. We document that, and we use that going forward. And that acronym is also used in service registration, in service configuration, etc.
And this is pretty much also something
turned out to be very effective.
Try to capture in those ecosystem guidelines. So those guidelines give the teams the safety to do the right things. And if they don't know or if they don't understand fully the guidelines, then this is something which we have to do in the onboarding events so that all the teams know what they have to do, and we get an overview of the whole ecosystem.
There's another question there.
So you mentioned use of multi-phase roles. Do your developers actually have space developer, or do you have tooling on top, like Jenkins, for example, to coordinate activities?
Yeah. You're asking whether we automated deployments, etc.?
Yeah, more do your developers actually have the space developer role?
Yes, at this point they have a space developer role. Again, we trust them because they have their isolated space. They cannot cause any disruption. And I think this also goes back into this organizational change that Thomas was talking about before, right? I know it also from other setups where there is still the mentality that people don't want to give out permissions and they are very careful, but this essentially slows down the development. It also has a psychological impact because if people are not able to push things into production, potentially they will create other code compared to as if they produce code that is pushed into production. So essentially, it turned out to be a very well-working concept. So every developer, or most of developers, get the space developer permission and are responsible from development up to higher level environments to maintain the application. And that also includes Jenkins, etc. A question here.
So what you're asking is whether there are updates which we communicate with regards to PCF or with regard to our ecosystem?
Right, so the first question is really just how do you enable your developers, how to work with the platform, how to use it, do you do internal workshops, or do you have some written guidelines, or
Yeah.
how do you actually do that?
So actually, if a team starts anew in our platform or ecosystem, then we have onboarding sessions. Or back-end onboarding sessions or service onboarding sessions, as well as the front-end implementation sessions. And then we have ecosystems, so the people get introduced to our ecosystem, to the guidelines, and they still have maximum freedom. So of course we cannot cover everything, but we cover most of the things which are efficient and sufficient enough to really get the teams going and have them implement their functionality. Anyway, if those teams, and as I said, we have several teams, if they have problems, they come to us and ask us, and if we think or deem this to be valuable for the ecosystem guidelines, because well, they touch subjects or topics which everybody should know about, we just integrate them in the ecosystem guidelines.
Yeah, and I think just to add to that, so we started out with giving those onboarding sessions and training, but we also found that this is not enough. So that's why in the lessons learned we said that we also want to provide all development teams that what we call toolbox, right? So things like a Maven archetype, because once you have a mature, platform, there's a lot of plumbing and configuration to be done, and it's really much easier than going back and forth, with support calls and you need to configure Eureka there because you need to include the major version, stuff like that, right? It's easier to create that Maven archetype once, or we also expanded into things like we created Jenkins pipelines. We have a shared Jenkins library used by Jenkins pipelines that is also created, or the generated code out of the Maven archetypes also creates those Jenkins pipelines. We also have a Cedar job on Jenkins that automatically sets up the necessary deployment jobs. So I think it's very important to incorporate that as well. Yes, please.
So if I could continue that thread a little bit.
Yes.
How long do you allocate for bringing a new team on, whether it's a new application development team or a service team?
Well, the question is how long it takes for a team to really become productive.
How long do you plan for that to take? Because
Yeah.
you thought it was going to be shorter initially, but you realized it's
Yeah.
actually
Yeah.
longer. What is it now?
So it depends, of course, on the knowledge of the teams. So if the team is, knows about to a factor apps or cloud native applications, then it's much faster. If they don't know anything about that, or if they really need to get educated about it, it takes more time. So you cannot really say it takes 2 weeks or 1 month. It really depends on the experience level of the teams. But if a team is very knowledgeable in implementing cloud native applications, I think after 1 week you have the team really to get going, also with the ecosystem guidelines. And then I think around 1 month will be the time, and after this 1 month the team is really fully productive.
All right.
Okay, so thank you very much.
Thank you.
As I said before, if you have any questions and we want to discuss this in detail, come just up to us.
All right.
Thank
Thank you
you.
very much.